All right, welcome back. So this time we're going to go a little bit into fine-tuning, RAG, and knowledge bases in Bedrock. But before we get started, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. So Amazon Bedrock offers approaches for customizing foundation models. Two of them would be fine-tuning and continued pre-training. These methods embed domain-specific knowledge directly into models, but differ fundamentally from retrieval augmented generation, RAG. This provides context at query time. So how do you do this? All right. Fine tuning. All right. All right. So fine tuning uploads prompt completion pairs. All right. Let's go back to this one. All right. So these are question and answer examples, chat dialogues, or brand voice samples. And Bedrock adjusts foundation model weights to create custom models. Right. This embeds behavior directly, eliminating the need to include example context in every prompt. You achieve better brand alignment and can bake proprietary knowledge into responses. However, fine-tuning is compute-intensive, time-consuming, and incurs significant upfront costs. It requires careful dataset preparation and validation. Once trained, the model's knowledge is frozen until you retrain. Okay. Then you have continued pre-training, which I don't see on this page. Okay, we'll go. All right. So continued pre-training. So continued pre-training provides raw, unlabeled text. This could be business documents, emails, technical manuals, and Bedrock adapts the base model to that domain knowledge. This adds recent data or internal corpora without ongoing prompting overhead. Like fine-tuning, it's compute expensive and often takes hours to complete. Supported models for both approaches include Amazon Titan, Text G1 variants, Cohere, Claude, Llama 3, and Nova series. For secure training on sensitive data, Bedrock supports VPC and private link configurations. So understanding RAG. So retrieval augmented generation functions as an open book exam for LLMs. Rather than relying solely on training, Bedrock retrieves relevant context from your data at runtime and appends it to prompts. External data stored in knowledge bases gets enriched into prompts dynamically. RAG offers significant advantages. It's updatable without retraining, enables fresh or proprietary data inclusion, and may reduce hallucinations when context is provided. However, prompt token length increases with retrieved context, raising tokens costs per query. So retrieval relevance depends heavily on chunking strategy and dataset quality. Outputs remain non-deterministic and require evaluation. So read. Make sure you read. All right, so let's go into vector stores. All right, so knowledge-based ingestion follows a clear workflow. You can upload documents to S3 or via a third-party connector. Right, Bedrock will chunk the documents. The default will be about 300 tokens, but sentence, paragraph, or custom Lambda-based chunking are available. So it generates embeddings using foundation models like Titan embeddings v2, and these embeddings and metadata get stored in vector stores. The default is OpenSearch Serverless with options for Pinecone, S3 vectors, or Redis. And so embedding vectors represent semantic meaning. Proximity in vector space indicates relevance between query and document chunks. Okay, so how would you do this in the console, right? So you say we're in Bedrock. All right, let's see. Where is knowledge bases? All right. So from here, create. Let's see. All right, so you name all this, description, use an existing role. Let's just use that one. Then your data source type. All right, tags. All right, let's just use that. Bucket. All right, use your strategy for parsing how your data is processed. Basically, you're chunking, right? Oh, you could do custom KMS for S3. So let's see, the Bedrock default parser. Yeah, that's fine. All right, chunking strategy, default, fixed size. So, this is where we're talking about that 300 tokens right here. Okay, hierarchical, semantic, no chunking. All right, we'll just stick with the default. All right, you have the lambdas. So this lambda can customize the chunking in documents with the metadata. So we don't have a lambda, so we really can't do this. That's why it's optional. This is KMS for transient data storage. Yeah, use that default data deletion policy, delete. Yeah, we want that. Okay, so we configure the data storage. which means, look, select embeddings model, convert your data into embedding, right? So we'd select that model here, boom, Titan V2, apply your vector store. So you could provide or auto create a vector store. So OpenSearch offers the managed infrastructure. Vectors can reduce costs compared to OpenSearch, especially for large scale deployments. All right, so you create a new one or use an existing one. Oh, there we go. A lot of different stuff. All right, so let's just do S3. Let's see. Oh, I have to get. Let's just do quick create, right? So we hit next. Oh, S3. The valid vector store is. All right, let's just use OpenSearch. All right, because this is what it's set up for. All right, so we're just doing tests. We don't need something for large volume. Redundancy for active. No, we don't want that. We do not want that. Next, this is just a review. All right, so we have the review page. You can see the knowledge base name, the service role to provision everything, the base type for this, the data source for that S3, data source name. All right. Oh, we don't have a CMK. We don't have any encryption chunking. We have the account, S3 bucket, we have the embeddings model, vector dimensions for tokens. No, that's vectors. And then OpenSearch. And we create it, but we're not going to do that. All right. So after this, you can start testing the knowledge base, right? Since we don't have anything in that S3, we're not going to do that. It would be ineffective, right? So under this, you would go over under. Why am I not seeing knowledge bases here? Hope you're seeing it. Hope you're yelling at the screen. Knowledge bases. There we go. So you'd be under knowledge bases. You'd be here, right here, where it would be listed. Then you could select the models, do the queries, examine the results, and then you could see the relevant chunks. You can augment the prompt with context and see if the queries are working. And then you can review the retrieved chunks, right? Okay, so out of that. Okay, so let's go to this. So advanced chunking, we talked about this a little bit earlier. So recent Bedrock enhancements offer sophisticated chunking beyond simple token counts. Semantic chunking groups sentences belonging together conceptually, improving retrieval relevance. Hierarchical chunking creates parent-child relationships between large context chunks and specific detail chunks. Lambda-based chunking enables completely custom logic via Lambda functions, defining chunk boundaries. All right. And then let's see, cost management. Oh, I don't have the cost up here. All right, so fine-tuning, pre-training, and charging, fine-tuning and pre-training charge for tokens processed during customization plus model storage. Knowledge-based ingestion bills for embedding generation and vector storage. Each retrieval query incurs search costs and LM inference tokens. So you use RAG for volatile or large data sets instead of frequent retraining. Chunk thoughtfully to balance retrieval relevance against vector count. So the more chunks means higher storage costs, but potentially better retrieval. Monitor costs carefully. All right. OpenSearch Serverless and embeddings both accumulate charges, while S3 vectors can dramatically reduce the storage expenses. And then you're going to automate your infrastructure with CloudFormation, Terraform, or SDK or CDK templates for a consistent knowledge-based creation and easier cleanup. So fine-tuning, all right, and fine-tuning, right? So when you create fine-tuning or continue pre-training jobs, you need to provide the training data from S3 in a JSON-L format with prompt completion pairs of raw documents. You can monitor the job progress and costs. Once finished, you can receive a new custom model ID for inference. And finally, cleanup. All right. So after testing, delete your knowledge bases, your data sources, and vector store resources to avoid ongoing charges. Vector stores particularly accumulate costs even when idle. So always clean up any experimental resources promptly, or else you're going to see a big bill. All right, for the exam, remember these essentials. When the exam asks questions about keeping models current with changing data, embedding proprietary knowledge, or balancing customization approaches, understanding the trade-offs between fine-tuning and RAG will guide you to the correct answer. So thank you for joining. Hope you appreciated this. Before we get going, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. Thank you. Have a good day.